Let's take a tour of the block diagram of AM Demo 1. This is a design for a real-time interactive front panel, and it's based on an event structure embedded in a while loop. The event structure has several different subdiagrams, and in this particular subdiagram, called the timeout diagram, this is where the actual algorithm execution takes place. I'm modulating my sinusoid, calculating the output signal, sending that to the audio writing device. Here before the loop actually starts, I configure the sound card according to the parameters such as sampling frequency and number of bits per sample and so forth. And this is embedded in a while loop, so it operates continuously. And if there's no other front panel activity, this panel, or this subdiagram, gets invoked every 10 milliseconds. And that's where you can see the 10 hard-coded to the little hourglass up there. So the timeout is where all the action happens in terms of creating our waveform. This subdiagram handles the interactive controls that we use while it's running, and the third subdiagram handles what happens when the stop button is pressed. Now again, during normal operation, the algorithm needs to know the normalized frequency F0 and the normalized frequency FM. That's our modulation frequency and carrier frequency. So the while loop continually passes that into the event structure. Anytime there's a change on the carrier frequency or modulation frequency controls, those are converted to normalized frequency here. And we do that by dividing by the sampling frequency. And then the value is passed to that shift register, which is part of our while loop. All right. So coming back to the actual algorithm, we see that the values get updated only as needed. That is, only when you actually manipulate one of the controls do those values get updated. But they're constantly being read by the algorithm. Again, here we see the 10 milliseconds time that if 10 milliseconds goes by, then we evaluate the timeout structure. Here's how you can actually specify which front panel controls get looked at. So this is a list of the event specifiers, and these are all based on a change in value. You can select from any of the front panel controls down here. You could even select indicators, because Y of T is an indicator actually. And when you select one of these, well, I probably wouldn't use that one. But when you select one of these, you can then choose which you want to use. Now, value change is the most common, but you see that you have a whole list. You can be working with the mouse, you can be doing keyboard shortcuts and everything. A lot of variety possible there. If you wanted to delete or add event specifiers, you can do that with those two buttons here. And as I say, value change is probably the one that you're most likely to use. And I'll cancel out of this so I don't disturb the existing structure here. Now let me return to the place where the actual algorithm is being invoked. Again, we have some initialization activities here. Specifically, this is defining the block size that gets used to generate a specific number of samples. That task ID is sent to the waveform write subVI, and when the loop ends, we have we take that task ID and essentially do an operation to clean up the sound card so it's ready for something else. I wanted to point out the labeling technique here. These are simply free labels, but they're kind of cleverly arranged so that it looks like they're actually part of the signal wire. The way you would make one of these is pretty simple. What I've done here is just placed a free label. Get your tools palette visible and select a background color of white. Or actually that would be the border color and the background color are both white. And then to kind of give the sensation of the signal flowing from left to right, you can just use some angle brackets in there. And you can place these on top of a wire, and that looks nice. This is a really important documentation technique, because when these are left off, for example, let me delete these temporarily. It won't take you very long at all before you forget what those wires are, and it's just confusing. You have to keep hunting back through the rest of the diagram to figure out what those were. So these labels are vital to good documentation when you print this out, and then when you're trying to edit it later on. So tip of the hat to Peter Bloom, who in his LabVIEW style book pointed out this suggestion.